About a week ago, I posted this on my YouTube community page that I had picked up some old FPGAs from Xilinx. And the bottom one in this picture is this Spartan, and it's a Spartan 3AN is the one that I'm working with there. And I've had a previous video where I just walked through maybe a potential dev board for that, and I've made some changes to it since then, and I'm going to continue to maybe improve it and make changes based on this latest PCB that I have coming in that's for a larger ICE 40 BGA. And so I'll take lessons learned from that and apply it to this Spartan 3 board before I order that up. And I'm still reading through documentation, reading through and looking through schematics that are reference designs. And I have a couple of reference boards that I've received in that I'm going to kind of play around with too. But then there's this upper FPGA in this picture, and this is, I think, even an older one, and it's an XC5215. And that's one that I maybe have more concerns about. Can I really get that up and running? Bottom one, I know it's old, but it seems like you can get the tool set easily enough off of AMD's website. It seems like the supporting chips are pretty standard. There's really nothing too special there. But this top one is a little bit different. So maybe some of the challenges, and I do have a blog post started on this on my blog, and I'll track what I'm learning as I go. But one of the first things that comes to mind that's a concern is any specialized chips required, supporting chips to support this XC5215. So that's one concern. Another concern is there really is not much out there for reference information on this. Now, Xilinx has good documentation, and AMD has done a nice job of making that documentation available for the most part. This specific set of data sheets I actually found on a different website, and I'll flip over to that in a little bit. But generally, Xilinx and AMD documentation is good. But what I'm not finding much of is reference designs. So I don't find a bunch of dev boards out there with schematics that I can look at, or just even simple schematics out there about how this Xilinx is typically configured up. So it's an XC5200 series, and I've been looking for that and not finding a whole lot. So I've got a concern of maybe specialized hardware to support this, maybe reference designs lacking that or lacking the information I'm going to need. And then there's also the whole tool chain and programming. How am I going to actually build something, configure Verilog or whatever it might be that I'm going to put onto this? Do I have access to the tools? And it seems like the tool chain that supports this is really old. And I thought I would just talk through some of those things real quick and show you that I do have a PCB that I think is pretty close to orderable. And the question is will I be able to actually get this FPGA fired up? Now, let me maybe start out with just the documentation from Xilinx for a minute. So here's this data sheet basically on the XC5200 series FPGAs, and I can come down and see that the 5215, which is the one I have, is the biggest in that series, and it looks like it's got a lot of capabilities, up to 244 IO, depending on the package that you're using. My package that I have will not support that because mine is a smaller QFN or QFP package. But I can read through this, a lot of good information here, and I've been working my way through this, just kind of learning about this a bit. But as I've been researching it, what I found is the latest tool set that supports it is a really old tool set. And I put this on my blog page over here, and maybe I'll just zoom in. And the tool set is something specific, this Foundation Software 3.1i. And that's old. You can't even download it off of AMD/Xilinx's website. So it's not available. You have to go find it elsewhere. And then, of course, you've got to make sure you can find whatever appropriate key to activate it, whatever it might be. But then you also have to wonder, what can I run that on? And I was able to get that tool set fully up and working. And what I'm going to switch over to is I'm just going to remote into a PC. It's a little workstation that I have sitting here. And when I get into this, it's an actual physical machine. It's not a virtual machine. So I'm connecting just to another it's a little Dell box sitting on my network. And specifically, it's a little Optiplex 780. So this is an old Dell. It's a little small form factor PC, but it has a built-in parallel port. And the reason I want the built-in parallel port is that I am going to use a Xilinx parallel cable 4 to actually program this FPGA, or at least that's my intention. So on this system here, if I go into Device Manager, you'll see that I actually have a true, LPT port, LPT1. I've configured it in the BIOS to be using mode ECP. And the next step then is, can I get drivers so that I can get this device working? Well, I ended up installing the Xilinx Foundation Series 3.1i software. So this is not ISE. This is prior to ISE, I believe. So this is old. But in that, there's a bunch of startup stuff, and there are some accessories, and here's those tools that seem to get installed with that. But one of the first things I wanted to see, could I just get into the JTAG programmer and have it recognize that parallel cable? And so if I open this up, I can go to output and I can set up the type of cable. And so there's a parallel option. And they have a nice little auto detect. And if I choose that, it finds that cable programmer fine. So that's a good sign. Now, a couple quick notes on this. I'm going from the parallel port. This is the first time I've used a parallel port probably in a decade, if not 2 decades. It's been a long time. But I'm going from that parallel port to the parallel cable. The parallel cable, that requires an external 5-volt supply. So I've got that plugged into it also. And it shows it powered up, and this is able to connect to it fine. I did set the BIOS again to use ECP. I don't know if that's required, but that seemed like the right setting to use as I was reading up on it. And then another note is, when I was setting up Windows, I first set up a 64-bit version of Windows 10. This is Windows 10. And when I pull this up, you'll just see I'm running this build number. So this is Windows 10 22H2 is the version. So it's a pretty new one. But what I initially had done is done the 64-bit version. And what I found is that the drivers for this JTAG programmer, the parallel cable, did not work. I didn't even try to resolve that. I just simply nuked the OS, reinstalled a 32-bit, and everything is working fine. So maybe the takeaway is, if you're going to try to get this old software running, look for Windows 10 32-bit. Now, one downside to that is that this system has a whopping 12, let me pull it up here, a whopping 12 gig of memory, but with Windows 32-bit version, you can only access 4 gig, and then I've got 1 gig that I think is getting set aside for video. I do have a discrete video card, so there's a separate Quadro K420 video card in here, or whatever I've got in here, but I think it's taken a gig of system memory, setting it aside for video. That ends up leaving me with a few gig of usable, and just sitting idle, I'm at 1.5 gigs. And it shows that there's 9 gig that is reserved for hardware. Technically, 1 is for the GPU, and 8 is unusable because it exceeds the 4 gig limit of Windows 10. So that's the downside to this. Maybe if I get really bored at some point, I'll come back and see if I can get the parallel cable drivers working on a 64-bit. But I just didn't want to mess with that right now. It didn't seem necessary. And I think this 4 gig or 3 gig usable will be sufficient. But the programmer seems to see this programming software, the JTAG programmer seems to see the adapter, which is good. Then the next question is, does this for sure support this FPGA? And there is an editor. I know nothing about the software yet, so I'm going to have to learn this. which will be, I'm sure, quite fun. But I did see this thing that was titled FPGA Editor, so that sounded like a good place to go in and see, could I create a project? And I can select a part. So that would be a nice win if I could see my part in there. So I go through the list, and during the install, you can choose which families you want to support. And I installed everything. But there's the XC5215 family. I've got the 15, and then the package I have is the 160 pin, the PQ or QFP here. And then mine is, I think, the slowest, the -6, if I'm not mistaken, is the slowest in that list. And then that's all there. So I can now say okay to that, and then I'd start working through the software. But that just shows me that at least the software is recognizing that this is a supported part that I should be able to work with. So that is good. And then I look through all this other stuff, and I don't know anything about any of these yet. So I'll come back into this at a later point. Like what's the chip viewer? I don't know what that is, and I don't even know what it's looking for to try to open. So more for me to learn, and I'll start working through that at a later point. Now, one bonus, I can actually remote into this desktop, which is great. On my Lattice toolset, you can't do that. I cannot remote into a different system that's running the Lattice software for working with the FPGAs, because it says, so the licensing throws up an error and says you've got to be basically at the machine. You can't do it remotely, which is a huge bummer. So it's great to see that I don't have that limitation here. So I think I'm sitting good on the whole dev environment. I think this is up and running. It's seeing the parallel cable. Now, of course, I've not tried to actually program a chip with that parallel cable, so that'll be the next step. But I'm thinking if the PC, the software recognizes the parallel cable, that programming adapter, that's a good sign. The tool chain here seems to recognize this specific part I'm using. That's a good sign. So then that gets me into, okay, I now need to figure out, is there any specialized PROM or ROM or anything like that that I need to be using? And I put some of this information up on my blog, but as I got into it, the answer is, well, yeah, it's expecting this XC5215E one-time programmable ROM, basically. And so I can go look that up and say, okay, well, tell me more about that, and there's information about it. And these you can find, but they're not readily available. Either you're going to pull off parts of an existing board, or you're going to find someone that has, little batches of them for sale on eBay, but you can't go to DigiKey or Mauser or something like that and get this part that I've been able to find. So this isn't a stock part. So then the question is, what are the alternatives? And I did find some posts about from AMD or from Xilinx at the time, I suppose. It was, well, maybe you could go to this XCF02S and use that platform flash instead. And so I looked into that, and those really, I think they're available, but they're just as expensive. These first ones, it seems like I could find for $6 each, but my concern is it's one-time programmable. And for me as a hobbyist, that makes no sense. So that's more of a production build type of thing. This one here, though, is reprogrammable and in-circuit reprogrammable. So that's good. Might be about the same price, maybe a little bit more, probably about the same price, I think, as I find these. And I did order some of these up. Actually, I ordered some little PCBs that have these on them that I can probably experiment with, take them off and use them if I want to. But then I was looking to see if I could get some more commodity type of serial flash of some sort. And so I did find that there's some alternatives. There's this ATT, so an AT&T 17128F, and it's a serial E squared configuration ROM. So I would probably need two of those, a pair of those, to give it enough space. It seems like that's available. It's more expensive than the previous options, and it is reprogrammable. And I kept digging, and I found that there's also an Atmel, if I'm pronouncing that correctly, AT17LV256. that is stocked. So I can go to DigiKey. I think I can go to Mauser. They're just in stock. I can just order those up for $10. And I did find a larger version, capacity-wise, that is actually less expensive. So Mauser and DigiKey have these for about $7 US. And that's the one I think I'm going to use. So then I do have a data sheet for that. And, I can look at this and see that, okay, it is an FPGA configuration EEPROM, supports a full voltage range. You can either do 3 or 5 volt, which is great. There's different sizes. I need at least the 256 here, but I could probably go with a larger one. I just wouldn't use the additional space. So as I search for availability and pricing, I found that the 512K was less expensive than the 256, either more available and or less expensive. And then I can come down, I can read about it, I can see the different packages. And I want to actually go with this package here. It's a good old PDIP. I'm going to put it in a socket. That way I don't have to buy a bunch of these and surface mount them. If I buy a small number of them, I can just move them from project to project as I go. And at $7, that's not a big deal, but it would be nice not to have to do that. These actual FPGAs I'm using were $1 or $2. They really were not expensive. I'd have to go back and double check, but very, very little cost there. And it seems a little odd that the supporting, flash here is more expensive than the main FPGA, but that's just how it is where I'm at getting these parts. But I'm going to put these in a socket so that I can move it from project to project. So that maybe got me through that. And as I was reading up in the data sheet, they do talk, of course, about, what type of, let's see if I can find it, the recommended PROM that they want you to use. This is, again, from the data sheet, back to that old one-time programming one. But there's other ways to configure this when it turns on. And one of them that caught my eye was pretty interesting. And that's using just a good old parallel flash like this, or it says EEPROM. But what I'm going to do is maybe also experiment with just a good old-fashioned SST39SF, and I'll probably use the 040. Technically, the largest I would need is this 20. But what I'm going to do is probably build the schematic to take the 40 because they're more available and typically less expensive than the 20s. So it's the highest capacity of these. It's the 512K by 8. Basically that 4 megabit type of setup here versus the 2 or the 1. And since I already have a stack of these and they are inexpensive when you buy a bunch of them, that might be even another option. Now, the downside of that is it takes up a lot more space. I have to now come down to work with a package that, looks more like this, or depending on which version you go with, maybe you don't have all of the same, you don't have as many pins. You can drop down from 32 to 30 to 28, I suppose, is the lowest pin count, but maybe that's not right. I'd have to double check that. Maybe they are all in the same physical package. It's just some of the pins aren't used. But anyways, I'm going to go with the 40. So then like over here, this first pin is used for address 18. With that, maybe I'll jump over to Easy EDA Pro here. And this is what I've put together so far. And again, this is maybe my first pass through it. Some things to point out, you notice I stamped all over here 5 volt only. So when I plug things into these connectors, I actually disconnected, I believe, the 3.3 volt rail. And so if you've seen my previous videos, I've been using this kind of standard connector setup. And I just I took off the 3.3 volt rail because there is no 3.3 volt on this board. It's all 5 volt. And so when I get back into this, that's just my reminder. And that's also a reminder that if I plug anything into it, this is going to be sending out 5 volt signals, not 3.3. And I have to be careful with that if I have a board that I'm going to connect that was intended for 3.3. Now, the upside of this being a 5 volt is this might work really well on some of my older 286, 386, 486 builds where I want to do something with the 5 volt signals, because those are all 5 volt, or at least the ones I've been building are all 5 volt. So that's maybe maybe exciting that I could use this FPGA. So to get a high pin count FPGA and have it be native 5 volts, no voltage level shifting, that could be pretty exciting if I can get used to working with this, programming this FPGA. Obviously, I'm not going to do anything too crazy on those. It's a lot of address decode logic, timing, things that it's doing to make sure that I'm accessing ROM, RAM, peripherals, things like that correctly. What else do I have on here? Same power connector I've been using. You can see over here, here's that flash. And again, I'm going to support the 40. I think I left enough space that I should be able to put a ZIF socket here. So I tried to leave other stuff a little ways from it so that I could put a ZIF socket here if I chose to do so. I've got an oscillator. This is going to be a 5 volt oscillator. There's a reset, some pins to get to the power rail. And then I do have that other flash memory, that serial flash memory right down here. So I'm trying to configure this that I could go either. I could use this, and if for some reason I can't get that to work, I could maybe use this as my fallback plan to use this type of a flash. I have my programming header. You'll see some of these little tiny pin headers. Those are just for maybe like down here, I've got a question on one of the pins if I want to use a signal called done or a signal called LDC, but this lets me pick one or the other. So these are just tiny little jumpers that I can set or not maybe put jumpers in, just simply solder how I want to use it. That's about it though. So, as far as capacitors, I've got those on any of the VCC type of lines on the back. I've got a few other surface mount components on the bottom when I just wanted them out of the way. And if I go over to the schematic, what you're going to see here is just the same old basic, my connector in, some capacitors, LED, power indicator. Here's the FPGA itself. And you can see a bunch of 5 volt. Hopefully I don't have any 3 volt in here. I think I've cleaned all of that out just to make sure I don't have anything that I might have copied over that's 3 volt. Here is that flash ROM or flash EEPROM, that flash memory basically that I'm using. And you can see I'm just taking this highest address line and tying it to ground because I don't need that address line. So I'm going to run it through a 0 ohm resistor to ground and just basically say, okay, let's just treat this as half the size. I'm only going to use half the size of this chip. But if I go back to the documentation I was seeing, they're showing up to address 17. And I don't think all of that is needed for a single program, but you could have alternate programs at different addresses. So that gives some flexibility. But I've got that in there and should be workable. I've got mode selects, and so this will help me set jumpers right here. And for example, I might say I want to boot off of this serial flash, or I want to boot off of this parallel flash up here. And that would be done with these M2, M1, M0, or mode 2, mode 1, mode 0. And that's that header. My programming header, and that programming header I think is a little bit simpler. There's potentially an init line that I could connect here. I don't know if I need it, so I put it through a jumper just in case I don't want it. I'll just leave that off. If I want it, I'll just short this and pull a NIT into this. Data in done in C clock. And then I don't know if I need anything on this pin. As far as I can tell, I don't. So I'm just going to run it down to a little header and do nothing with it, but give me a nice soldering point if I do need to connect it to something later. And then 5 volts and grounds. Here's that serial flash that I'll be using. And this should be a drop-in replacement for the one-time programming version that was recommended in the data sheet. And like here is where on one of the signals, I've got 2 different pieces of literature I'm reading. One says to use done, one says you use LDC. So I'm just going to put a jumper option here so I can pick which one and experiment if I need to. Here's my prog B and a reset switch. And here's some of the literature that I was finding. Well, this is kind of a standard how I might set up that port, and I'm kind of going down this path of the slave serial. And then here is a let's see, a little bit of information. I think this is from the data sheet for the for the FPGA, showing how to connect into this. Again, their one-time programming version of that PROM. But that shows me that. And then I did find in this AT17 series, they also have some documentation and say, okay, from a Xilinx FPGA, this is how you might connect in and also go up to a header. And they're doing a different format header that I'm not going to use. But other than that, I just then ran, of course, all of the address and data lines over here. But then down here, I took what was left for IOs and brought them down. You can see this port has quite a few IOs on it. This other one, maybe not as many, but that's the remaining available IOs. Now, I should say that all of these IOs that I have coming over here to connect to this, as soon as the FPGA is up and running, you can reuse these IO for other things. I'm not doing that in this initial design, but keep that in mind. I'm not just wasting those IOs just for this. That was my first thought, is, oh, that's a lot of IOs just to get my boot up going. But once it's booted up, then you can repurpose those. So I can have those connect to something else in addition to that flash. So that's where I'm at with this. Maybe an ask I would have for any of you is, if you've done anything with this 5200 series before, are you aware of any available reference designs or schematics or other things that I could look at just to kind of get a little bit better feel for, am I missing something in my schematic? Is there something that would be helpful if you have any references out there? I've been doing some searching and I just have not had a lot of luck, really no luck at all, finding any reference designs or sample schematics at all. I think this was just simply too old. I can't say before the internet, but I just can say that there just isn't a lot of content online that I can find related to this specific FPGA. I'm much more optimistic now that I do have the tool chain up and running. I have a programmer that I think is going to work. I have, I believe, a couple of options on how to actually get it programmed. Of course, the serial would be the preferred. And if I can get this board up and running and do something really basic, like connect to one of my cards with LEDs on it and flash some LEDs, that would be my next indicator that things are moving in the right direction. But if any of you have any references, resources out there for the XC5200 series, I would be grateful if you could drop me a note or send me some info. And I'll keep going through documentation just like I am for that Spartan 3. I'm still, reading through a whole bunch there. That's going to take me weeks. And same with this. I'll probably spend another couple of weeks reading on this FPGA and the design. Hopefully, I think JLC PCB is almost done manufacturing my 256 ball ICE 40 FPGA, so I'll need to get back to that. I also am working on a serial interface for my ICE 40, and then I'm working on the static RAM usage on the ICE 40. So those are all things, all plates I have spinning right now, but I thought this one I'd at least kind of get it started, see if I could get some feedback. And then, of course, if I order this, that'll take a few weeks to get it in. So that's why it's kind of nice to throw these on order and then jump back to something else that I have the PCBs on hand. So really old FPGA, maybe some good signs that I'm getting close to actually being able to use it. If you got any feedback, questions, comments, drop a note below in the discussion. Thanks.